This lesson is about how to graph the tangent and cotangent graphs. We'll start with the tangent graph, which is sine over cosine, or y over x when looking at the unit circle. There's a few things that are different about these graphs versus the sine and cosine graphs. Starting with, on these graphs there are some asymptotes. So remember, an asymptote is just a place that the graph cannot touch, and in this case these are vertical asymptotes. They happen if x equals 0. So anywhere that the cosine is equal to 0, we have an asymptote. Let's look at our unit circle and figure out where those places are located. So on our unit circle, anywhere the x value is 0. The first time we get to one of those is right here at pi over 2. That's our first asymptote. Have that marked on your graph here, so go ahead and write that in at pi over 2. If you keep circling around, the next place it happens is at 3 pi over 2. And if you continued in that fashion, it would happen again at 5 pi over 2, 7 pi over 2, on and on and on. If I went backwards, it would happen at negative pi over 2. So I want to see where it happens on both pieces of the graph. I want to go ahead and mark my highest point, and I say that lightly, and my lowest point as negative 1 and 1. We know those are significant here. And let's go ahead and mark some points in between. So halfway in between here would be pi. Halfway in between here would be 2 pi. Go ahead and mark those. Now, what we need to look at when we're talking about tangent is the y over x. Let's start at 0. If I look at y over x, I've got 0 over 1, which is 0. So I'm going to make a mark there. If I go to my next value, let's go halfway between pi over 0 and pi over 2. That'd be at pi over 4. If I look at pi over 4, I've got root 2 over 2 over root 2 over 2. That's my y over x. Y over x in that case is 1, so I'm going to make a mark at 1. Similarly, if I go here to 0 and go halfway between 0 and negative pi over 2, which is there, I'm at negative pi over 4. At negative pi over 4, I've got negative root 2 over 2 over root 2 over 2, and that value would be here at negative 1. Now, what do the things look like around that? Well, we know these vertical asymptotes are places where the graph hugs it. If I think about something between pi over 4 and pi over 2, for instance, pi over 3, and I think of the root 3 over 2 over 1/2. That'd be root 3 over 1, or root 3. And if I put root 3 into my calculator, I get 1.7. Okay, 1.7. So that value is really fairly high and getting much higher. My graph then looks something like this. And that's just kind of a sketch. That's really as good as we're going to be able to get. You could always put tangent of theta into your calculator if you like. Be sure you're in radians and kind of see what that looks like. But this is the sketch of the graph. This is the parent function. Now, one thing I want to connect for you is that tangent is the same as the slope. Remember, slope is y over x. So if I think about slope at 0, my slope, if I look at this little string, is 0. It's a horizontal line. That's true here. If I go to pi over 4, my slope is 1. Guys, look at this. This is the same as it would look if I was talking about my parent function y equals x. It'd be going through 1, 1, 2, 2, 3, 3, 4, 4, and on and on. If I went all the way up to pi over 2, my slope becomes undefined. It's a straight vertical line. That's true here as well. At pi over 2, it's a vertical asymptote. So I hope that kind of connects those ideas for you. Going back to the graph, let's look at our period. It goes from negative pi over 2 to pi over 2, which is the distance of pi. So that's the period. There is no amplitude when we're talking about tangent, or cotangent for that matter, because it comes in from negative infinity and goes to positive infinity. So that fills in 2 blanks. That would be my range. Negative infinity to positive infinity. My amplitude does not apply. And then my domain, it goes from all kinds of thetas, but we have to exclude everywhere that there's an asymptote. So x does not equal negative pi over 2, pi over 2, 3 pi over 2, and on and on and on. And I could say 5 pi over 2 and all of those that come with it. That's kind of understood with those little dots there. Let's look at the cotangent. Cotangent is the relationship of cosine over sine. My asymptote then would happen when the sine of theta is equal to 0. So anywhere the y value is equal to 0, we've got a problem. Well, let's look at our unit circle and figure out when that happens. My y is 0 at 0. So there's an asymptote here at the x-axis or the y-axis. That's the first one. The next place that happens is at pi. then again at 2 pi, 3 pi, on and on and on. It also happens at negative pi. If I go halfway in between, at pi over 2, I know that my x over y is 0 over 1, so that's 0, where that happens. Halfway in between that would be pi over 4. At pi over 4, I've got root 2 over 2 over root 2 over 2, which is 1. So put a mark up here at 1 and put a dot there. Also, if I go halfway between pi over 2 and pi, that'd be at 3 pi, I'm sorry, I got stuck there, 3 pi over 4, excuse me, 3 pi over 4, and that'd be negative root 2 over 2 over root 2 over 2, which would be negative 1. So I'm going to put a mark there and draw my dot. Now, if I draw my graph this way, that's what the cotangent graph looks like. And let's sketch that in between. That repeats itself over and over and over, always crossing kind of right in the middle. My period is from 0 to pi, so my period is pi. My amplitude does not apply because there is no highest or lowest. Again, the range is from negative infinity to positive infinity. And then my domain, the x values that I do not include, are things like 0, pi, 2 pi, on and on and on. So every interval of pi. Now, on the flip side, let's take a look at our transformations. We've got y is equal to a tangent of b times x minus c plus d. If you want all the specifics on that, go back and look at your notes about sine, because they're all right there. But I just want to remind you that a changes our amplitude. I say that lightly. In this case, it'll just change our midpoints of 1 and negative 1, if that applies. B changes our period. Our new period for tangent and cotangent can be found by doing pi over b. The reason that happens is the pi is our period, so to get our new period, we're dividing by b. C is a shift left or right. Remember, that's opposite of what you think. And D is a shift up or down. I'm going to show you 2 examples and then do one with you from your homework. Example number 1 is that if y is equal to the tangent of negative x over 4 plus 1. There are 1, 2, 3 things going on here. The first is that I've got a negative in front of my x, which causes me to have a flip. The 4 is like multiplying by 1/4, so b is 1/4. So our new period is pi over 1/4, which would be like doing pi times 4 over 1, or 4 pi. That's my new period. And this plus 1 tells me that I'm moving up 1. Now, the reason I know it's not moving left 1 is because it's not inside a parenthesis group. Okay, to graph this thing, let's go ahead and draw our x and y axis, or our theta and tangent axis. We know that tangent normally splits the origin. So it splits here, it's normally at pi over 2 and negative pi over 2. In this case, it's splitting our period up, which is normally pi. Half of pi is pi over 2. Half of 4 pi is 2 pi. So I've got 2 pi, and the other side would be negative 2 pi. And the next place that something would be happening would be 4 pi, and then 6 pi. My next period would be 2 to 6 pi. And I'm going to draw asymptotes at my halfway mark. So I'm going to go ahead and do that here, and here, and here at 6 pi. You don't have to draw any certain number of periods to show me that you get this, but go ahead and do just a couple so that I can kind of see. We know that halfway in between, it's definitely, well, we know it's shifted up, so we're going to have to wait on that. We've taken care of the period. The next thing that we're going to do is where it would normally cross here at 0, it's moving up 1. So it's right here. I'm going to kind of extend that line for you. So that's where it's going to cross. Same thing here at 4. Now, my tangent normally goes from bottom to top, but it's flipped, so it's going to go the other way. My not amplitude, but still my points of interest then would be 2 and 0. So here, this one, instead of going from down to up, this one would be here. This one would be here. And my graph would look something like this. Notice that I'm giving you a very rough sketch here, but I've still taken every piece into account. It has been flipped, because normally tangent would go in this direction. It has changed the period. It's now negative 2 pi, which is a total of 4 pi. And it's been shifted up by 1, so it crosses through 1 instead of through 0. And that's all of my transformations. Let's try another example, number 2. y is equal to the cotangent of 2 times x minus pi over 2. This time, of course, we're talking about the cotangent graph. Let's go ahead and draw in our axes to begin with. The 2 is changing my period to pi over 2, and there's nothing to reduce there. That's my new period. This negative pi over 2 tells me that I have a movement right of pi over 2. So that's something different, right? A movement right. Normally, my graph would have an asymptote at 0, and then the next asymptote would be at pi. In this case, it would be 0 and pi over 2, so let's just draw a mark at pi over 2. Do another one at pi, and just go in increments of pi over 2 just to have a reference point. That's something that you'll have to choose and just get better at as you go along, but I'm just going to start there since that's my new period. Normally I would have an asymptote here and here. I'm moving right by pi over 2. So what was here is now going to be moved right here. But what was here is now moved here. So actually that doesn't change anything in terms of our asymptotes, which makes this actually easier than we had originally intended. And so now we've just got our regular cotangent graph. It's going to go through halfway at 0, and it's in this direction here. And that's just a sketch using that parent function. I can do it 2 times or 1 time or 3 times. As long as I show at least 1 or 2 periods, I should be good to go. Okay, the last thing I want to do is go over one of your homework problems. So this doesn't need to be in your notes, but maybe you'll want to pause here and get this down, or just pay attention so that you can come back to it later. And that's number 8 from your homework. It says y is equal to 1/4 tangent of x. Now, your book uses x instead of theta sometimes. Those two things mean the exact same thing, so no worries there. The thing that I want to show you here that's different is that there is a change in a, in the amplitude. What can be confusing about that is that there is no amplitude when we're talking about tangent and cotangent. So let me kind of clear that up. The way that you fix that is instead you're going to do 1/4 here and negative 1/4 here instead of marks at 1 and 1. The period hasn't changed, so it's still pi. Tangent, remember, splits the distance around the origin. So I've got marks at negative pi over 2 and pi over 2. Those are my asymptotes. I'm going to go ahead and do one at 3 pi over 2 as well. Again, I want to see a couple of periods there. And everything else is normal, so it's still going to cross at 0. This is going to be my, maybe we can call it our high point. This is going to be my low point. And I just draw that in between. And that's it for that one. Go ahead and look at your homework. Do the best you can. The homework assignment is A7, and that is page 339. You're going to do number 7, 8, 19, 22, 24, and 30. Good luck, and I'll have questions answered when I get back.